Alright, in this video we're going to be looking at some of the parameters for binomial distribution. So we'll revisit some of the formulas for the mean, the variance, and the standard deviation that we talked about for a regular probability distribution, but this time the formulas are going to be a little bit easier when you're dealing with a binomial distribution because you're only dealing with success or failure, which is going to be two outcomes. Alright, so let's start off with those parameters for a binomial distribution, which is of course the mean, the variance, and standard deviation. Okay, now if you recall, I gave you these formulas that deal with the parameters for a regular probability distribution, and they might have been a little bit more complicated for you to use. Now here, the ones that we're going to be using are quite easy, because for the mean, it's just going to be this formula: mu is equal to n times p. And in this case, n is the number of successes, p is your probability of success. Okay, so n, I'll just say number of trials. And p is your probability of success. And then for the variance is sigma squared. And that's going to be the product of n, p, and q. Again, n is the number of trials, p is your probability of success. If you recall q, that's going to be the probability of failure. And do keep in mind that q is always equal to 1 minus p. So if you know what p is, then you can easily find out what q is. It's simply 1 minus p. And once you know the variance, the standard deviation is quite simple, because that's simply taking the square root of the variance. So it'll be sigma is equal to n times, equal to the square root of n times p times q. Okay, so those are your parameters for a binomial probability distribution. Okay, and the next thing I'm going to talk about is the range rule of thumb. Okay, and it's important that we interpret and understand those values, so the range rule of thumb is going to be very helpful. Okay, and those values are going to be unusually high or unusually low if they differ from the mean by more than 2 standard deviations. So in this case here, the minimum usual value is going to be this: mu minus 2 times sigma. That's the mean minus 2 times the standard deviation. And then your maximum usual value is simply mu plus 2 times sigma, or the mean plus 2 times your standard deviation. Okay? And you'll be applying that range rule of thumb to some of these problems. And we'll look at examples that are related to just using the mean, the variance, and the standard deviation for a binomial distribution. So in this case here, here's some examples. Last year, a person here we go. Right, in a clinical trial of a cholesterol drug, 498 subjects were given a placebo. and 7% of them developed headaches. For such randomly selected groups of 498 subjects given a placebo, identify the values of N, P, and Q that would be used to finding the mean and standard deviation for the number of subjects who developed headaches. So what we need to find out is what N is, what P is, and what Q is. Alright, N, we're dealing with 498 subjects, so that's what N is equal to. Your P, 7% of them develop headaches. Well, 7% as a decimal, that's 0.07. And Q, well, we know what P is. Q is always going to be 1 minus P. So it'll be 1 minus 0.07 or 0.93. So Q will be 0.93. And that's all we have to do in that particular problem, because it just says identify the values of N, P, and X that we would use to find the mean and the standard deviation. Okay, now, number 2, this next example. Assume that a procedure yields a binomial distribution with N trials and the probability of success for one trial is P. Use the given values of N and P to find the mean and the standard deviation. Also use the range rule of thumb to find the minimum usual value and the maximum usual value. Okay, so we know what N is, that's 1476, and P is 1/2. Well, let me change that P, which is equal to 1/2, to 0.5. And if P is 0.5, Q has to be 1 minus P, or 1 minus 0.5, which is 0.5. So now we can find the mean of the set of data. And the mean in this case would be this. That's your mu, and that's equal to N times P. And in this case, your N is 1476 times P, which is 1/2 or 0.5. So 14 times 0.5 would simply be 738. So the mean there will be simply 738. Now for the standard deviation. To find the standard deviation, we use this formula. Sigma is equal to the square root of N times P times Q. So in this case, your N was 1476 times P, which is 0.5, times Q, which is also 0.5. And we can type all this into the calculator. So in this case here, I have second x squared for the square root of 1476 times 0.5 times 0.5, and then hit enter. Let's see, to one decimal place that would be 19.2. So the standard deviation there would simply be 19.2. So the mean is 738 and the standard deviation is 19.2. Now we want to use the range rule of thumb to find the minimum usual value and the maximum usual value. So your minimum usual value is this. That's mu minus 2 times sigma. Your mu was 738 minus 2 times sigma, which is 19.2. So if you do 738 minus 2 times 19.2, you get 699.6. And then for the maximum usual value, that's going to be mu plus 2 times sigma. So in this case here, your mu is 738. This time it's going to be plus 2 times 19.2. So if you type in 738 plus 2 times 19.2, you'll get 776.4. So your minimum usual value will be 699.6. Your maximum usual value will be 776.4. Okay? Alright, here's another example, similar to that one. Assume that the given procedure yields a binomial distribution with n trials and the probability of success for one trial is p. Use the given values of n and p to find the mean and the standard deviation. Also use the range rule of thumb to find the minimum usual value and the maximum usual value. In an analysis of preliminary test results from the gender selection method, 10 babies are born, and it is assumed that 50% of babies are girls. So n is equal to 10 and p is equal to 5. Well, in this case, if n is 10 and p is equal to 5.5, then q is 1 minus p, or 1 minus 0.5, which is 0.5. So for the mean of this binomial distribution, that's mu is equal to n times p. And n is 10 times p, which is 0.5. So 10 times 0.5, which is going to be 5. And 0.5 is 1/2, so half of 10 would be 5. So the mean there would be 10. And then for the standard deviation, that's your sigma. That's going to be the square root of n times p times q. So here we got the square root of n, which is 10, times p, which is 0.5, times q, which is also 0.5. Okay, now I'll go ahead and show you how to type that into the calculator. Second x squared for your square root, then 10 times 0.5 times 0.5. And that will be approximately 1.6, rounded to 1 decimal place. So your standard deviation there would simply be 1.6. And do pay close attention to how many decimal places they ask you to round in the homework as well. So now we want to find the minimum usual value and the maximum usual value. Your minimum usual value, that's always going to be mu minus 2 times sigma. And mu was 5 minus 2 times sigma, which is 1.6. So 5 minus 2 times 1.6 will be 1.8. So the minimum usual value will be 1.8. Now for the maximum usual value. That's going to be mu plus 2 times sigma. Now this time, mu is 5, but you're adding 2 times 1.6 this time. So that's going to give you 8.2. So your minimum usual value will be 1.8 and your maximum usual value will be 8.2. Okay. Alright, now let's look at the next example. Several psychology students are unprepared for a surprise true-false test, and all of their answers are guesses. Part A, you're going to find the mean and the standard deviation for the number of correct answers for such students. Okay, so let's start off with part A. We have 10 true-false questions, so that's your N. they're either going to get the answer correct or incorrect because it's a true-false test. So the probability of getting it correct will be 0.5, which means Q has to be 0.5. That's 1 minus P. So now the mean, which is your mu, that's N times P. That's going to be 10 times 0.5, or half of 10 would be 5. So the mean for that situation would be 0.5. And then for the standard deviation, that's sigma, and that's equal to the square root of N times P times Q. Well, N is 10, so it'll be 10 times, P is 0.5, and Q is 0.5. And all of this is underneath a radical. And I think I did an example like this before, so your standard deviation here will be 1.6. When you take the square root of 10 times 0.5 times 0.5, it'll end up being 1.6. So your standard deviation is 1.6, and the mean is going to be 5. Part B is this. Would it be unusual for a student to pass by guessing and getting at least 4 correct answers? Why or why not? Well, we need the minimum usual value and the maximum usual value. Well, the minimum usual value is going to be mu minus 2 times sigma, or in this case, mu is 5, so it'll be 5 minus 2 times 1.6, and that's going to end up being 1.8. And then for your maximum usual value, that's going to be mu plus 2 times sigma, or 5 plus 2 times 1.6, which will end up being 8.2. I believe these numbers are similar to the last example that I just did. So your minimum usual value is 1.8 and the maximum is 8.2. Now, would it be unusual to get at least 4 correct answers? And in this case, the answer would be no, because 4 falls between these two usual values of 1.8 and 8.2. So in this case here, we can say no, it is not unusual. And that's because the number 4 falls between 1.8 and 8.2. Okay, here's the next example. A candy company claims that 14% of its plain candies are orange, and a sample of 100 such candies is randomly selected. Now in part A, you want to find the mean and the standard deviation for the number of orange candies in such groups of 100. We want the mean and the standard deviation. So here, N is 100, because we're dealing with 100 such candies. The probability of orange candies was 0.14. That's given to us. And then Q is just going to be 1 minus P, or 1 minus 0.14, which will be 0.86. So we can find the mean and the standard deviation. The mean, mu, is equal to N times P. N is 100 and P is 0.14. So 100 times 0.14 would simply be 14. Not only that, that mean is also what we call the expected value. So if the candy company claims that 14% of its candies are orange, and we have 100 candies that are randomly selected, we would expect to see 14 orange candies. Now for the standard deviation. and that's sigma equaling to the square root of n times p times q. So we got the square root of n, which is 100, times p, which is 0.14, times q, which is 0.86. Okay, now if you take the square root of second x squared and then 100 times 0.14 times 0.86 to one decimal place, it will be 3.5. So the standard deviation there will be 3.5. So that's part A, finding the mean and the standard deviation. Part B is this. A random sample of 100 candies contains 24 candies. Is this result unusual? And does it seem that the claim rate of 14% is wrong? Okay, let's get the minimum usual and the minimum and the maximum usual value. The minimum usual is always going to be mu minus 2 times sigma. Here, your mean was what, 14? Minus 2 times sigma was 3.5. So 14 minus 7 is 7. That's your minimum usual value. Now for the maximum usual value, we're going to have mu plus 2 times sigma, which will be 14 minus 2 times, no, 14 plus 2 times 3.5, so 14 plus 7 would be 21. So the minimum usual value is 7, and the maximum usual value is 21. Now, in that sample of 100 candies, there were 24 orange candies. Here, 24 is outside the usual limits of 7 to 21. So that result would be unusual. So 24 candies, or 24 orange candies, is unusual. And by this particular situation, we can say that the claim that 14% of the plain candies are orange would be wrong, because we came up with an unusual number of 24. That 24 is outside those limits of 7 to 21. Okay. We've got a couple of more examples that are related to binomial probability distributions. In a clinical trial of a drug used to help students stop smoking, 814 subjects were treated with 1 milligram doses of the drug. That group consisted of 38 subjects who experienced nausea. The probability of nausea for subjects not receiving the treatment is 0.0094, and we want to complete parts A through C. Part A is this: assuming that the drug has no effect, so that the probability of nausea is 0.0094, find the mean and the standard deviation for the numbers of people in groups of 814 that can be expected to experience nausea. Okay, so in part A, this is what we have. We have 814 individuals, or 814 subjects. The probability of experiencing nausea is 0.0094. So that means Q is going to be 1 minus P, or 1 minus 0.0094, which will be 0.9906. Okay? So it's best to get that done first, so that way we can find the mean and the standard deviation. So here the mean, which is of course n, mu is equal to n times p. So n is 814 times p, which is 0.0094, Multiply that out, you get 7.7. So the mean will be 7.7. And then for the standard deviation, that's sigma, which is equal to the square root of n times p times q. So your n is 814, your p is 0.0094 times q, which is 0.9906, and all of this is underneath the radical. So if you take the square root of 0.814 plus 0.0094 plus times 0.9906, you're going to get 2.8 to one decimal place. So that's your standard deviation of 2.8. Now part B is this. Based on the result from part A, is it unusual to find that among 814 people, there are 38 who experience nausea? Why or why not? So here we need the minimum usual and the maximum usual values. So here your minimum usual values. Minimum usual value is just going to be mu minus 2 times sigma. Your mu was 7.7 minus 2 times sigma, which is 2.8. So 7.7 minus 2 times 2.8 will be 2.1. So the minimum usual value will be 2.1. Now for the maximum usual value. That's going to be mu plus 2 times sigma. Your mu is 7.7 plus 2 times 2.8. Well, 7.7 plus 2 times 2.8 will give you 13.3. So your range of usual values will be from 2.1 to 13.3. Now, we're dealing with 38 who experience nausea. Well, the number 38 is outside these two limits here, so it would be unusual. So in this case, 38 people experiencing nausea from a drug is unusual. Okay, because the number 38 is on the outside of those limits here of 2.1 and 13.3. Now part C. Based on the preceding results, does nausea appear to be an adverse reaction that should be of concern to those who use the drug? Okay? And the nausea rate, although it's quite low, it does appear to have an adverse reaction. Okay? So that might be of concern to those who use the drug. Okay? So in part, I'll just say that it does appear to be an adverse reaction. But you're dealing with 814 people, so 38 out of 814 is not that much of a, it's a small percentage. Okay? So it doesn't happen very often. Okay, last example. If a gambler places a bet on the number 7 in roulette, he or she has a 1 over 38 probability of winning. Part A is to find the mean and standard deviation of the number of wins of gamblers who bet on the number 7 190 times. So in this case here, N is 190, and the probability of winning is 1 over 38. So Q is 1 minus P, or 1 minus 1 over 38. Now I'll show you how to type this in to get the fraction part. Okay, so 1 minus, and then I'm going to put in parentheses 1 divided by 38, close your parentheses. Then you're going to press this math key, and then you're going to select number 1 for fraction, because you want to turn that answer into a fraction, which will be 37 over 38. So Q will be 37 over 38. Okay. So now the mean, which is mu is equal to n times p, and that's equal to n, that's 190, times 1 over 38. Okay, and then we show you how to type this into the calculator. 190 times, parentheses, 1 divided by 38, close parentheses, hit enter, you're going to get 5. So the mean there will just simply be 5. And then for the standard deviation, that's sigma equaling to the square root of n times p times q, and that's the square root of n, which is 190, times p, which is 1 over 38, times q, which is 37 over 38. Okay, now let me show you how this is typed into the calculator. So second and x squared for the square root, 190 times, left parentheses, 1 divided by 38, close parentheses, times, left parentheses, 37 divided by 38. And then you have to close your parentheses for the 37 over 38, and then you have to close it again because at the very beginning, that parentheses was open. Hit enter, you're going to get 2.2 as your standard deviation. So that standard deviation there is 2.2. Alright, so that's part A. Part B, would 0 wins in 190 bets be an unusually low number of wins? Okay, let's get the minimum usual and the maximum usual values. So the minimum usual value is going to be mu minus 2 times sigma, and that's 5 minus 2 times 2.2, which will end up being 0.6. So the minimum usual value will be 0.6. Now for the maximum usual value, that's going to be mu plus 2 times sigma, where mu is 5 plus 2 times 2.2, well, 5 plus 2 times 2.2 will be 9.4. So the range of usual values will be 0.06 and 9.4. Now, for 0 wins, 0 is less than 0.6. Okay, so 0 wins is unusually low. Okay. Okay, it's unusually low because that's outside the range of usual value. So winning 0 times will be unusually low. Okay, so that will conclude this particular video on the parameters of a binomial distribution.